Hello and welcome to another chemistry topic. As you can see, the topic today is chemical formulas. Go ahead and write down the date that you are taking these notes. So to put this into context of what we've been talking about in this unit, we talked about atoms, what it means to be an atom versus an ion versus an isotope, and the identities of atoms. We talked about bonding, introduction to why do atoms come together to make a compound instead of saying an element. This idea of 8 valence electrons and chemically stable and that kind of stuff. So, what we're learning about today is kind of like the language of chemistry. So, we have a name such as something like barium phosphate or iron 3 sulfate. And the idea is okay, these words mean something to us in terms of a formula. Like, why is there 3Ba here? And why is there parenthesis and a 2? Like, what does that stuff mean? That's what we're going to learn today. So go ahead and write and set up your essential question, your focus notes for today. The essential question you should be able to answer when we are done with our notes today is, how do I write chemical formulas for ionic and molecular compounds? So these are compounds that have ionic bonding or compounds that have covalent bonding. It turns out that there's different rules depending on which type of bonding you have. So for our notes today, of course, I always like it when you write things down. I think it's useful for review later, helps you process, helps your brain stay more active. But I am going to give you a little bit of guidelines. In our notes today, you only need to write down the stuff that's in red. If you only write down the stuff in red, that will be enough. If you want to add more, that's up to you. But the goal of today is by the end of the lecture, no matter what chemical formula I give you, if you have your periodic table and you have your ion guide sheet, you can write the chemical formulas. So these will not be random letters and numbers and words to you, but they'll mean something. And that's kind of like, again, this language of chemistry that you need to know to be successful moving forward. So if you've not already done so, either print the periodic table and the ion guide sheet, which are in today's Schoology folder if you need them, or put them into Notability because you want to have access to them as much as possible. You don't want to have to download them every time. You don't want to have to search for them on the internet. You want to make sure you have your own copies that you can mark up and highlight and put little notes on them if needed. So either print them or put them into Notability. Let's do this. Okay. So the first thing, so again, if you're taking notes, I recommend you just write the stuff in red. So the first thing you would write down is writing formulas. First example, what if we're dealing with a metal and a non-metal? If you look at the periodic table, remember there's that stair-step line that starts between boron and aluminum going across, and then it goes down, over to the right. On the left side of that stair-step line are the metals. On the right are the nonmetals. So if we're taking a metal element from the left side of that stair-step line, combining it with a non-metal element on the right side, these are the rules for writing that formula. These are ionic compounds, meaning that the resulting answer when we're done writing the formula would technically be called a formula unit, which remember we abbreviate that FU. So it's one of those times you get to say that and not get in trouble. So metals plus nonmetals, those are ionic compounds. That's the type of formula we're talking about first. Well, that means we need to review oxidation numbers. Remember, there is a separate little bit less than 5-minute video on how to find oxidation numbers. If you haven't watched that yet, I would highly recommend you watch that because I'm using this video kind of assuming you already know how to do oxidation numbers. The definition of an oxidation number, remember, is a positive or negative number that every element has telling us how many electrons need to be lost or gained in order to be chemically stable, like the nearest noble gas. So for example, find chlorine. Look at it over there on the right. Do you see it? Okay, so because of where it is, it needs to go forward one spot, and then it will be in the noble gases, and it would be considered chemically stable. That means it has a -1 oxidation number because it needs to gain 1 electron to be stable. So now it has an extra electron, it's negative. Well, that's not stable either, but it gets it closer. Strontium, another element on the periodic table, way over on the left, go find it. Find it? Okay, what would its oxidation number be? Can you figure it out? Look at where it is. Count backwards is closer. How many spots? Okay, so a +2. So that's how we write the oxidation numbers. Notice they're above like exponents. That's where they go. And the reason it's a +2 charge is because it needs to lose 2 electrons to be stable. So here's the kicker. This has a positive charge now because it lost electrons. Where did it lose those electrons? To chlorine. Chlorine was trying to gain electrons. Chlorine took 1 electron from strontium, and then probably another chlorine took the other electron from strontium. So then now total, you'd have 2 negatives and 2 -1s and 1 +2. So overall, they balance each other. So the idea here, so this is what you're writing down for notes is, when ions come together to make a formula unit, their oxidation numbers balance to zero. That's the big idea. So we're doing a little bit of like chemistry math with positives and negatives. So the idea is if I times this by 2, that would be a total of -2. That would balance out this +2. So then what that means is the formula unit that would result is 1 strontium and 2 chlorines all connected to each other to make a neutral, balance to zero oxidation number compound. That's the chemistry that's going on with a little bit of math to help us figure it out. All right, so we're dealing with binary compounds, and like a bicycle that has 2 wheels, a binary compound has 2 parts, a positive piece and a negative piece. That's what we're focusing on. So calcium bromide, a first name, last name, 2 parts, binary. That's what we're learning about. So this happens to be an ionic compound. How do I know? Calcium is a metal. How do I know that? It's on the left side of the periodic table where the metals are. Bromide, we're going to learn that that "ide" ending means that we're talking about an element. So you'd find the element that is closest to bromine or bromide, which happens to be bromine or bromine. So here's what we do. When you're given a name, you confirm that the first word is a metal. Is calcium a metal? Yes, it is. That means you need to write the symbol and the positive oxidation number. So you'd look up on the periodic table, find calcium way over there on the left. Do you find it? The symbol is Ca. And the positive oxidation number is +2. Why is it a +2? Because look at where calcium is. If it goes backwards 1, 2 spots, that gets it all the way back to the noble gas column, which is considered stable. Bromide, now that's going to be the symbol with the negative oxidation number. So again, that "ide" ending means you're looking for an element that sounds like bromide, and it's bromine or bromine. The symbol is capital B, small r, and the negative oxidation number is a -1. Why is it -1? Look at where bromine is on the periodic table. If it goes forward 1 spot, it'll be in the noble gas column in terms of electrons. Negative because it's gaining an electron to get stable. All right, so step 1, symbol in charge of the positive part. Step 2, symbol in charge of the negative part. All right, so the end, no, not we're done with notes, but I'm going to just make sure I make it clear about that ending. So a hint about the ending. If the chemical name ends in "ide," that means you're looking for the element. Any other ending, like you'll start to see "ite" or "ate," or those come from the ion guide sheet. So again, if you have not looked at that ion guide sheet, make sure you download that, print it, have it with your periodic table because you can look stuff up on there. So if we're dealing with something that's not an element, it has a different ending. And we'll learn later why do we change it to "ide." Big spoiler alert, it's because we want to show that they're bonded, they're connected. It's not just an element by itself. There are a few exceptions to the "ide" thing, like for example, on the ion guide sheet, there is a group called hydroxide. So yes, that ends in "ide. It turns out it's not an element. However, it's on the ion guide sheet, so you can find it, especially because hydroxide kind of sounds like hydrogen, kind of sounds like oxygen. So how would you know which one? Well, it turns out that it's both. It's OH with a -1 charge. Another exception is cyanide. It ends in IDE, so we would first think, oh, maybe that's an element. But if you look on the periodic table, there's no element that sounds anything like cyanide. There's nothing even close. So then at some point you'd be like, oh, I bet it's on the ion guide sheet. So you'll get to know them just the more you get to see your ion guide sheet and the more you get to use it. Okay, so back to this idea. So step 1 was symbol in charge of the positive word. Step 2 was symbol in charge of the negative word. Step 3A is, if the oxidation numbers already equal 0, then you just put the 2 symbols together and you're done. So you don't need any subscripts, you just put the 2 symbols together. So like for example, Mg is a +2 charge on the periodic table, oxygen is a -2. So they are a perfect match. You would just need 1 Mg, 1 O, put the 2 symbols together and you're done. No subscripts, no parentheses, nothing extra, because this is giving away 2 electrons. This is gaining 2 electrons. They're what I refer to in chemistry as a perfect match. Just put them together, you're done. It just looks like this. Ones are assumed, so we don't put Mg1O1. It's just extra stuff we don't need, because if you wrote the element, there has to be at least 1. Anything 2 or higher, we do write. So just know you don't have to write ones for anything in our symbols or even when we balance equations. Ones are assumed because the element is written there. Any other numbers we would need to write. Okay, so let's review. We've got symbol in charge of the positive, symbol in charge of the negative. If they balance already, so the total plus equals the total minus, just put them together, you get your answer. So then the last piece is, well, what if they don't balance? So that's 3B. If the oxidation numbers don't already equal 0, figure out how many of each you need so that the positive and the negative balance. Neutral is what we're going for. So how about sodium oxide? Sodium is a metal. The symbol is Na with a +1. Oxide sounds like oxygen, so that's O with a -2, all right? So if I have one sodium with a +1, that doesn't balance my oxygen -2. Oxygen needs to take 2 electrons to be stable. It takes one from that sodium, and it's halfway there, so it needs to find another sodium and take its other electrons to fulfill that oxidation number. It needs to be able to take 2 electrons. So then if I have 2 sodiums, they each give an electron. Now these 3 particles, these 3 ions all connect and they make a stable neutral formula unit, meaning we've got now 2 sodiums and 1 oxygens, but we don't write ones. So the answer would look like this, Na2O. So this is what 3B is showing. If the oxidation numbers don't equal 0, because a +1 and a -2 don't match each other the way that +2 and -2 did in that previous example. So then we had to do some chemistry math. You can write it out like this, or you can do it in your head. What matters is that you get the right answer and know what this means. 2 sodiums balance 1 oxygen, because this is each sodium is giving away an oxygen to the each sodium is giving away an electron to the 1 oxygen that needs 2 electrons. And then now this would be a formula unit. It is stable. Notice there's no charges written anymore. All of these little details matter. The more you practice, the more you'll get comfortable with this. All right, let's do an example. So remember, the first thing we do is we confirm that the first element is a metal, telling us we have to balance the charges. So lead 2 phosphide, do this example with me. Lead 2, find where it is on the periodic table. It's kind of in the little bit right to the right of the middle, but it is still on the left of the stair-step line, so lead is a metal. This Roman numeral 2 tells you that lead has an oxidation number of +2. If you didn't remember that, you would look on your ion guide sheet, and it tells you lead is Pb. The 2 means a +2 charge. Phosphide, remember that "ide" ending tells you to find the element closest to phosphide. So what element sounds like phosphorus? Phosphorus. Okay, so phosphorus is capital P. Take a look at where it is. It's kind of over on the right side. And if you look at its oxidation number, it's -3. So, I was going to break this down in steps for you. I've just been talking through it. Let me show it to you. So step 1, remember, is the symbol and charge of the first word. So that's where I got the Pb +2 from the ion guide sheet. Phosphide, so this is now step 2. We already figured out that this was the element phosphorus. We find it on the periodic table. It's closer for it to go forward. It goes forward 3 spots, which means it will be a -3. All right, now take a look at this though. They do not match each other. That's a 2 and that's a 3. But we can do some math to make them equal to the same number. So 2 and 3, what common multiple do they have? No, 1, nope, 2, nope, 3. Oh, 6, right? So if I times this by 3, that will equal 6, +6. If I times this by 2, that would equal -6. So then it will be a total of +6, a total of -6. The charges balance. So that's what we're doing here. So Pb +2 and another Pb +2 and another Pb +2 means that total 1, 2, 3, 4, 5, 6 electrons are being lost. -3 plus -3 is -6. That means that 6 electrons are being gained. So the total amount of electrons lost has to equal the total amounts of electrons gained, because otherwise it wouldn't be a stable formula unit. So then when we write the answer, we've got 1, 2, 3 Pbs and 1, 2 phosphoruses. So Pb3, P2. Notice how we write it. We don't put big numbers in front. They're not exponents. The answer has little numbers down below, and there's no more charges. That is an important detail. The charges are balanced. They are neutral. Your answer has to be neutral. Otherwise, it's not a stable compound yet. All right? Think through what we just did. Do you get it? Symbol and charge of positive. Symbol and charge of negative. Make the charges balance. Final answer is neutral. That's our summary so far. Think about this. See if it makes sense. Jot down any questions you have, and you can ask during office hours. You can send me a message. You could review this. See if this makes sense. Do you got it? Okay, let's do a few more examples. The first thing we're going to do is we're going to make sure that the first element is a metal, which tells us we have to balance the charges. We're going to show our work just a little bit, which just means showing the ions. Let's do 3 examples together. Sodium sulfide. Sodium, is it a metal? Yes, it is. It's on the far left of the periodic table. Its symbol is Na. Its charge is +1. Sulfide means we're looking for the element that sounds like sulfur. Sulfur. Okay, so capital S, -2. So there's my step 1 and step 2. Step 3 says we got to check to see if the charge is balanced. They don't right now, but I can find a common multiple, 2. If I multiply this by 2, it's a +2 charge. If I multiply this by 1, it's a -2 charge. So my common multiple they agree on is the answer of 2. This times 2, this times 1. The final answer looks like this. 2 electrons are being lost. 2 electrons are being gained by the sulfur. This is my stable formula unit. Let's try another one. Barium oxide. First, we check to make sure that barium is a metal. Look at where it is. Yep, it's on the left side of the periodic table. Its symbol is Ba. Its charge is +2. Oxide means find the element that sounds like oxide. Oxygen, I find it. Yep, capital O, -2. Barium is a +2, oxygen a -2. Perfect match. So then that means their answer is just one of each of them. 2 electrons are being lost. 2 electrons are being gained. I don't need any other multiples or numbers, just one of each. That's your final answer. Let's do one more. Aluminum oxide. Aluminum, look at where it is. Oh, yeah, it's kind of just past that like middle part, but it is still on the left side of that stair-step line. So aluminum is a metal. And then if you count backwards, it only has to go back 3 spots. It could go forward, but that would take 5 spots. That's more work. It does whatever's easier. So aluminum has a +3 charge. The symbol is Al. Oxide, we just did, O with the -2. So this is another one of those times where you got to do some common multiples. 3 and 2 both have a common multiple of 6. So if I take this aluminum times 2, that's a +6 electrons being lost. -2, if I take this times 3, that's a total of 6 electrons being gained. The total lost equals the total gained. Put them together, 2 aluminums, 3 oxygens. That is the stable formula unit from the name aluminum oxide. So you're showing me you understand elements on the periodic table. You're showing me you understand the math and that the positives and negative charges mean electrons being lost and gained. So these are all skills that a chemist needs to know. All right, I'm hoping this is making sense. If not, you're going to jot down some questions. You're going to keep practicing. You're going to let me know if you need help. For now, though, take your first little break. A level 1 kind of question. So list the steps to write a binary ionic compound. That would be great. You could do some matching, you could do a description, something like that. Do a level 1 question. Go ahead and pause the video if you need to, and then come back when you're ready. All right, here we go. The next piece is, well, what if we don't have an element? What if we have something called a polyatomic ion? All right, poly means many. Maybe you're familiar with that term. Atomic is just meaning atoms. And then an ion, remember, is an atom with a charge. So what this means is that we have a group of atoms that still have a charge. So they've made a compound. It's just not a stable compound yet. They still need to gain electrons or finish losing electrons to finish making a stable compound. They just made a polyatomic ion because those were the elements available, but it wasn't enough to finish and make a stable compound. You have a reference sheet called the ion guide sheet. I've mentioned it a couple times. This gives you the polyatomic ion formulas and their charges. You don't have to figure anything out. So polyatomic ions are on the ion guide sheet. Remember, they are a group of atoms that they are bonded together. So they're one thing, one particle, and they still have a charge. They don't split apart and they don't change their formula. So you just copy them from the ion guide sheet and they follow the same rules that we just learned for binary compounds. Symbol in charge of the positive, symbol in charge of the negative, make the charges balance. The only thing that's different is you might not be just using the periodic table. You might be using an element with a polyatomic ion. When you write the formula, though, because it's many atoms behaving as one piece, there's one tiny difference we have to add, and it's parentheses. So go ahead and write this down. When there's more than one of a polyatomic ion, you put parentheses around that polyatomic ion to keep it together. For example, well, first, so the point of the parentheses is that it shows you that that group of elements stays together. You put a subscript on the outside of the parentheses if you have two or more of that group. Remember, ones are implied, so you wouldn't need any parentheses. So we might say something like this: Zn parenthesis NO2 parenthesis. This NO2 is something on the ion guide sheet. And it turns out that it has a -1 charge and zinc has a +2 charge. So we need two of this group, so that's what the parentheses are saying, to match one of this element. It's not the same as ZnNO22, two of this thing. No, it looks like you have 22 oxygens. That's not what we wanted to say. So just be careful. Those parentheses matter. The number outside applies to everything inside, just like in math. Numbers outside of parentheses factor in. So the subscript tells you you have two of everything inside here. 2 times N, 2 times O2, but this is a group, which is what that parentheses is telling us. So again, NO2 is a group of elements that have made a compound. They made a compound. It's just not a stable compound. So it needs to keep bonding with other things to make a stable formula unit. That's the idea that we're learning. Here's another example: ammonium sulfide. Ammonium is on your ion guide sheet. It's NH4, and it has a +1 charge. Sulfide, same rule as before. Ide means the element. Sulfur has a -2 charge. So because NH4 is a +1, we need two of that whole thing, ammonium, because you need to lose 2 electrons to balance and make the sulfur stable. The resulting answer is still a formula unit. It's still neutral. You're still doing the same kind of math. It's just that if it's a group element, you need to put those parentheses around it. Let's try a few more examples. So the first thing we check is the first thing a metal or an ion? Meaning we have to balance charges. So calcium, is that a metal or an ion? Oh yeah, it's an element, right? And it's a metal element on the left of the periodic table. Carbonate, okay, here's where that hint before will be useful. 8 endings mean it's not the element carbon, that would be carbide. 8 means, look at the ion guide sheet and write it down. So calcium is Ca with a +2 charge. Carbonate is CO3. Notice that the 3 is lower, saying there's 3 oxygens bonded to 1 carbon. This is a compound. It's just not stable. It still needs 2 more electrons to be stable. Where's it going to get those electrons? From calcium, because calcium can give away 2. So the final answer is CaCO3, calcium carbonate. This is a group. We don't need any parentheses because there's only one of them. Remember, ones are implied. You don't need any extra numbers. This is telling us that the total charges of Ca losing 2 electrons balances the total charges of carbonate gaining electrons. Let's try another one. Sodium sulfate. Sodium, we check to see that it's either a metal or a group ion. It is a metal. Sodium's on the far left of the periodic table, Na with a +1. Sulfate, that 8 tells you this is not sulfur. This is something, a group ion on your polyatomic ion sheet or ion guide sheet. So Na +1, sulfate, you just look it up, SO4 and a -2. So what does this mean? Sulfate is made of, the identity of sulfate is 4 oxygens and 1 sulfur connected. That's how it starts, but that's not stable yet. There's not enough electrons to make 4 oxygens and 1 sulfur a stable compound. So instead, it needs to gain 2 more electrons. Well, sodium can only give away 1 electron at a time, so we do our multiplying trick. If I have 2 sodiums, they can each give away 1 electron, so total 2 electrons are lost to the sulfate, which needs to gain 2 electrons. So Na2SO4, sodium sulfate. How about this one? Write this one with me. Ammonium phosphate. Now, ammonium kind of sounds like an element, sodium, calcium, ammonium, but it turns out that if you look on the periodic table, you'll never find ammonium, but you will find it on your ion guide sheet. So the first part is an ion, which means we have to balance charges. So write down ammonium from the ion guide sheet. It's like one of the first ones on the list, NH4 with a +1. Phosphate, that 8 tells you this is not phosphorus. It's a group ion on the ion guide sheet, PO4 with a -3. So NH4 +1, PO4 -3. Those are the 2 pieces. This group compound is not stable. It needs to give away an electron. This group compound, not stable. It needs to gain 3 electrons. But ammonium can only give 1 away at a time. So again, we do our multiplying trick. If I have 3 of these, that would give, each one would give away 1 electron. So I'd have 3 electrons being lost. This phosphate can gain all 3 of them and be stable. So we need the parentheses this time around this group only, because that's what you have multiples of. NH4 with parentheses on a 3 outside, PO4. The 4 stays because that's the definition of phosphate. There's no charges left because 3 times plus 1 is positive 3, balances out the negative 3. This is a stable compound. So let's review what we just did. Same steps as before. Symbol in charge of positive, symbol in charge of negative. If they balance, just keep one of each. If they don't balance, do the math to make them balance. The new thing is you might need to use parentheses to keep a group together and put the number on the outside. Think through that. Okay, do you get this? If not, jot down some questions. You can come to office hours. You can send me messages. And you can also do more practice because it's possible you're like, I think I get it, but I'm not sure. You just need to do some more examples, do some more practices, unit practice problems, the assignment. You could find stuff online if you need more practice. But the idea here is that you're learning the language of chemistry so that moving forward, you know what these symbols mean. Why is it this? What does this name mean? That's what we're trying to learn. All right. Okay, let's review what we've done so far. Process what you just have heard and learned. Out loud with this. For real, say this out loud with me. It doesn't matter if someone's around you or even if you're by yourself. Do this out loud. So for real, do it because that gives your brain more active learning instead of just sitting there being passive. So say this out loud with me. When the first element is a metal, say it, say it, say it, say it. This is ionic bonding. So say it out loud. We look up oxidation numbers and make the total positive charge equal the total negative charge. Okay, go back and repeat it. If you didn't actually do it out loud, do it. Do it. Say it out loud. Stop ignoring me. And then good job, partner. But you're kind of my partner right now, right? Because we're taking notes together. All right, go ahead and give yourself a self-high five because you might be by yourself, so we need to do that little celebration. So this is a summary of the first part of our notes so far. Everything has been ionic bonding, whether it was a group ion or an element ion. All the things we talked about have been ionic bonding. All right, go ahead and take your second break. Level 2 kind of question. Remember, these are like compare, contrast, or explain. Choose which rule to use. That might be not ready yet because we only have kind of one set of rules, but that might be a good level 2 question after we've learned all of our rules for writing formulas. All right, pause the video if you need to, and then come back when you're ready. All right. So the next part of our notes is, well, what if it's not an ionic compound or an ionic formula? What if it's a molecular formula? What if there's covalent bonding happening? So that's what this picture is showing. So these would be covalent bonds instead of ionic bonds. So when do we use these new sets of rules? Here's when we use them. If the compound is combining a nonmetal and another nonmetal. Remember, our ones so far have been either a group ion or a metal connecting to a nonmetal. These are covalent bonded compounds, molecules. And then remember, how do we know if it's a nonmetal? You look at the periodic table, anything on the right side of the stair-step line. So these are all of our nonmetals. If you didn't draw this in during our bell ringer time today, you should draw it in now. So it starts between boron and aluminum and goes down, around like stairs. Everything on the left of those stairs are metals, except for hydrogen. It's a weird exception because it's element number 1. But then everything on the right side are nonmetals. So if you're combining chlorine and phosphorus, carbon and selenium, iodine and fluorine, whatever it is, 2 things from this side of the periodic table, you're going to use these rules we're going to talk about right now. And it turns out it's all about the prefixes. So the first thing you do is you check to see, is that first element a nonmetal? If it is, you look at prefixes from the name and you just write down how many of each it tells you. If you aren't familiar with prefixes, there is also a list of 1 through 10. That's as far as you need to go for this class on your ion guide sheet. So if you didn't remember that di means 2 or tetra means 4, that's okay. You can look it up. It's on your ion guide sheet. So here we go. I have a color-coded example. Tetra, phosphorus, trifluoride. So first we got to check what the first element is. So somewhere in here there's an element name. Oh, here it is, phosphorus. Is phosphorus a nonmetal? Yes, it is. It's on the right side of the stair-step line. So because this first element is a nonmetal, we just look at the prefix and it tells us how many there are. So phosphorus is capital P. Tetra, look on the ion guide sheet. What does the tetra prefix mean? It means 4. Okay. Now we need to do the same thing with the second part. Fluoride. Ide means find the element closest to fluoride. It's fluorine. Capital F. And then tri means, what is it? Look at the ion guide sheet. It means 3. Put it together. So P for phosphorus, 4 for tetra, F for fluoride. and then 3 for tri. So tetraphosphorus trifluoride. That's what this is showing. Let's do another one. Carbon dioxide. Okay, so first element, is it a nonmetal? Carbon? Yes, it is. It's on the right side of the stair-step line. Oh, wait a second, but there's no prefixes. Wait, if there's no prefixes, how many must there be? Yep, you got it, just one. So capital C for carbon, dioxide. Oxide means oxygen, capital O. Di means two. So CO2. Now you might have been like, oh, wait, I knew that. Yeah, carbon dioxide, CO2. We talked about that in biology a lot, right? But now you know why it's carbon dioxide. Carbon because of C, di meaning two, oxide for oxygen, CO2. All right, do this one with me. Hexasulfur pentaiodide. Pentaiodide. Okay, so first element. What's the first element in this word? Sulfur. Okay, so then we look at the periodic table. Is sulfur a nonmetal? Yes, it is. It's on the right side of the stair-step line. Capital S for sulfur. Hexa. All right, we look at the list on the ion guide sheet. Hexa means, do you find it? It means 6. So capital S, 6 for hexasulfur. Pentaiodide. All right, so we have to recognize that pent is a prefix, and then iodide. Oh, okay, I got it. Iodide is an element. Iodine. Remember, ide endings means you find the element. So iodide, iodine, capital I. Pent means how many? Look on the list. 5. So I5. So here we go. S6I5. Okay, so hexasulfur pentiodide. That's the idea. Okay, hope you agree with this guy. You're like, oh, that's easy. The thing that makes this set of rules hard is remembering to do it. There will be times when you're trying to balance these charges, you're looking up the charges, you're like, oh, the charges aren't working. There is no charges for this type of bonding because remember, they're sharing electrons. They're not gaining and losing electrons, so there's no ions to deal with, which is why we need another set of rules with prefixes in them because we can't figure out the formula from balancing charges because there are no charges. Their oxidation numbers don't apply when you're dealing with a molecular compound. So don't forget to check if that first element is a nonmetal, just lose prefixes, not balancing charges. Let's review this. Okay, review our second set of rules. So out loud, yes, do it. Just do it with me. Out loud, repeat this. Metal plus nonmetal means ionic bonding, means balanced charges. Go, go, go. Okay. Nonmetal plus nonmetal means covalent bonding, means use prefixes. Go ahead, repeat that. Don't forget to check if the first word in the name is a metal or nonmetal. Go ahead, repeat that. All right, go ahead and give yourself a self fist bump again, because you might be by yourself. If someone's around you, you can feel free to get a fist bump from somebody else, but self fist bump, we got this. We're ready to practice, ready to keep going. All right, so this is your third brain break. You could do a defend or an imagine or a predict, or I don't know, design something like design a flow chart to help you remember how to name compounds. Oh my gosh, that would, or write formulas. That would be such a great level 3 question, so useful. Okay, now I actually have one more quick thing before you're done with your notes. So always check, put this at the end of your notes. Always check first element, metal or nonmetal. Metal, use oxidation numbers, make the total plus equal the total minus. Nonmetal, use prefixes. If you wanted to, you could even put this just as your summary for today. I'm okay if you copy down this. This will be a great summary. It answers our EQ. How do I write formulas for ionic and molecular compounds? This is how we do it. So feel free to write this in your summary for today. I'm okay if you just take it. You could also reword it on your own if you want to. So now that you've got all of this new information, you've seen some examples, we've talked through a bunch of notes, it is time to practice. That's how you're going to know whether or not this makes sense. So that brings us to the end of our notes for Unit 2, Day 3. Here's your to-do list. Go back and finish any COSTA questions. You can write your own summary, or you can use the summary that I just gave you. And I'm going to have you start the formula practice assignment. There are 2 pages of it. The second page goes with our next day. So Unit 2, Day 4, we're going to learn how to go backwards. If I give you the formula, what's the name? But today, it's what's given the name, what's the formula? So just try page 1. Of course, you can use my office hours if you have any questions or send me messages. We can set up a time. But the important thing is to practice it. Even if you're not sure if you're doing it right, just try it. And even if you get them wrong, that will help me understand where you're at and help you understand what part you're getting stuck on. All right. Thank you so much for listening to this topic today. This is going to help you become a better chemist. And plus the math and the problem solve and the math and the skills and the organization, all of that helps you problem solve, which just makes your brain smarter. Thanks for listening. We'll talk to you next time. Bye.